Hello friends, my name is Prasad DS and my technical seminar is about reservoir computing for early stage Alzheimer's disease detection. The contents are about introduction, objectives, challenges, literature review, methodologies, proposed systems, results and conclusions and references. So coming towards the introduction, Alzheimer's disease is a brain disease caused by the progressive destruction of nerves of various parts of the brain. It falls under dementia and umbrella terms describing the symptoms associated with the decline of the individual ability to think and memorize the information. The success and progress of artificial neural networks can be largely attributed to the increase in the depth and complexity with a consequential increase in the cost of training them. The disease interferes with the patient's work and social lives, making them incapable of handling everyday tasks. Aut- Automated systems are more accurate than human assessment and can be used in medical decision support system because there are not subjected to human errors. Based on previous research on AD, researchers have applied images, biomarkers, and numerical data extracted from MRI scans to study this disease. As such, they were able to determine whether a person was demented or not. In addition to shortening diagnosis time, more human interaction will be reduced by automatic automating Alzheimer's diagnosis. In addition, automation reduces overall cost and provides more accurate results. For example, we can predict whether a patient is demented by analyzing MRI scans and applying prediction technique. If a person has early stage Alzheimer's disease, they are considered demented. By doing so, we can achieve better accuracy. So, to brief the introduction, Alzheimer's is a brain disease which will be automated by using MRI scans and it will be detected through a machine learning process by giving the dataset through MRI scans. It will give the results as per the dataset and it will take less time compared to a human analysis and the analysis time will be decreased so that the patient's lifestyle can be improved for the disease to be reduced. So coming to the objectives, the main object is to present a fully automated deep ensemble approach for dementia level classification from brain images to compare different deep learning architecture to obtain more suitable which is one fit for the task, evaluating the robustness and the proposed strategy in a deep learning framework to detect Alzheimer's disease and recognizing different levels of dementia. The proposed approach is specifically designed to be potential support for clinical care based on patient's brain's image. So the datasets will be containing the MRI scans of the patient, which will be detected by the deep learning method. And depending upon the deep learning method strategy, the MRI scans of the patients will be compared with the datasets in the different dementia levels. And depending upon the dementia levels, the results will be given to the patient. So coming towards the challenges, the person who is having Alzheimer's, it is hard for him or her to remember the right word or the name and having difficulty in remembering names when meeting new people. Working in a social setting or workplaces every day can be challenging for them. Having forgotten something that I have just read in a book, something else will be forgotten by the people. Having trouble in finding or misplacing a valuable objects. Tasks and activities are becoming increasingly difficult to plan or organize the activities. So these are the main challenges of the Alzheimer's people due to the deposition of the protein plaques in the brain. The part of the brain which is used to store the memory will be affected. So these are the challenges will be upheld from the patients of the Alzheimer's disease. So coming towards the literature review, the first author is given under the title of Clinical Diagnosis of Alzheimer's Disease, and which was published in the year 1984. And the paper describes like clinical criteria for the diagnosis of Alzheimer's disease include insidious onsets and progressive implementation of memory and other cognitive functions. There are no motor, sensories, or coordination defects early in this disease. So the second author has given the paper under the title of Appropriate Use of Criteria for Amyloid PETs, and describes position emission tomology of brain amyloid beta is a technology that is becoming more available, but its clinical utility in medical practice requires careful definition. This paper was published in the year 1984, and the third author has given the papers under the title The French National Alzheimer's Database, and it describes the BNA offers a multitude of research possibilities. It will play a major role in monitoring trends and related risk factors in AD. This paper was published in the year 2014. This is a brief flow chart of the detection of the Alzheimer's. The MRI scans of the Alzheimer's disease patients will be categorized under various datasets, and the data pre-processing will take place, and in process of data pre-processing, removing noise will takes place. Removing noise means the MRI scans of the less pixels will be removed, and the detection of the proteins and the brains, which can be easily recognized by the machine learning process, will be kept under the datasets, and the data sets MRI scans will be split and to various datasets. I can say like training datasets and validation datasets, or the testing datasets, and which will go to the feature extraction and classification, and it will go to various neural networks which are used in the deep learning method, and by giving the MRI scan of a deceased persons can give the results as deceased one, also, and the MRI scans of a non-deceased person can give the results as no disease. So coming towards the methodology, I can say this is the detailed version of the previous slide which I have shown. So the first, model building. In model building, the datasets of the MRI scans of the various deceased or non-deceased and partially deceased MRI scans of the patients will be included under the data repositories, and those images of the deceased people will be sliced, and data pre-processing will be takes place. And second one is the model training. It will take under cloud and standalone, and in though the MRIs are stored in a cloud-based datasets which can be easily accessed in various systems, which will be helpful in which will be helpful in various ways, and the deep learning, and they will go under deep learning, and the models will be trained. You can see in the third one, those datasets will be exported to training models, and as that and the datasets will be loaded and the models will be trained. And coming towards the fourth one, model testing. uh, in previous slide I have said that the MRI scans will be split into testing data and training data. Those models will be given in various formats for the training of the machines, and depending upon those training data and testing data, evaluation of the models will take place. And depending upon the models of testing data, the accuracy of the model is detected. So to give the details of the previous slides, the first method that takes place in the methodology which I have proposed, net model, is to input images that we get from the MRI scanning, and the next step, the data pre-processing method starts. The step that takes place in data pre-processing are reshape, resize, one-hot, encode, and reshape. Reshape will be under 176 to notate into 3. After data pre-processing, handling and imbalance problems will start. The process of problem handling includes two main processes. They are SOMTE and TOMKE, and reshape 1. The synthetic minority oversampling technique algorithm is used to solve the above imbalance datasets issue. The oversampling the class to imbalance the datasets. Afterwards, the dataset is split into train, test, and validation, and percentage of 60%, 20%, and 20% respectively. In the next step, the process of splitting takes place. The data set is split into train, test, and validation by 60, 20, and 20 respectively. So the proposed systems, the SW data used in our work is cursive 4 data, where participants were asked to write 4 set of 4 letters, that is 4444 on a table from a pattern as shown in the diagram. The data were collected in a hospital in Paris from 54 participants, evenly split into 24 healthy controlled patients and 27 Alzheimer's disease patients aged between 68 and 86. They were collected using a large table at a sampling rate of 125 Hz. The table records x coordinate, y coordinate, pen pressure, pen azimuth, and altitude of the pen on it on a trajectory. So detection of the Alzheimer's can be used in bidirectional long short-term memory. Long short-term memory neural networks are specialized class of RNN with specialized gates that can store, read, and reject information from both recent and previous output further back in time. BiLSTM is a variant of LSTM that exploits simultaneously the past and the future, hence bidirectional in time, for computation, which makes it well suited for certain tasks, as shown in the figure to the right bottom. The principle of operation with classification having serial information proceeds in both past future and future past direction to give the output for processing the subsequent dense layers. Coming towards advantages and disadvantages. Advantages are it provides parallel processing, support to multiple links, allow us to export ROI for use in other packages, an excellent freeware viewer for medical images, user-friendly to analyze and visualize the image data, interface with other tools, provides complete processing pipeline for MR images. So these are the advantages. And coming towards the disadvantages, Requirement of high computational time, suitable for grouping analysis, compatible only with SPM programs, limited display models, memory consumption is high, the tool has limited scope. So coming towards the content, comparison of accuracies for all the models under consideration for the ESAD task. The by LSTM accuracy was 88% and SCNS for 96 and SPEC for 79, and digital RC is 85, 88 and 83 respectively, and the K modules are 74, 75.6 and 72.2. The accuracy obtained by LSTM counterpart is at 88%, which is an improvement over the digital RC model. Notice that the recurrent methods, that is digital RC and by LSTM, surpass both the CNN and K-Medeo's algorithm in accuracy. On that note, before we conclude that the YLSTM is indeed the best model here, we will analyze the costs that come with extra gain, 3% gain with respect to RC in accuracy of by LSTM in subsequent sections. So coming towards the conclusion, in this paper we have proposed that use of artificial neural networks for early stage Alzheimer's detection from the handwritten temporal data by studying the trade-off between accuracy and efficiency. And we have found that by LSTM and reservoir computing are the best approaches for the task compared to alternative methods using K-medeos and or CNS. Both methods shows an improvement in accuracy compared to state of the art, with the digital RC yielding an accuracy of 85%, that of by LSTM is 88%. That is an increase of 3% in accuracy for the by LSTM. We found that by LSTM and reservoir computing are the best approaches for the task compared to alternative methods like K-medeos, and so the accuracy of the by LSTM will be more due to the future past and past future recognition due to the backtracking and future tracking methods. So coming towards references, I have referred 5 papers for my technical seminar, and these are all the references which I have used. And thank you, and that's all with my technical seminar.